Hello everyone, in this video what we are going to do is that we are going to start with the second type of retaining walls that we have, which is our restrained retaining wall system. So this lecture is going to be a brief overview over our restrained retaining wall system, and then in our next lecture we will start with the analysis and design of our retaining wall system using ASDIP. Now, the first thing we need to talk about is, when do we know that we need to add a lateral support or add a restriction to our wall from the top? So let's take an example of a 7-meter wall, or a wall with a 7-meter height. So this wall is going to have a stem thickness of 0.7 meters, because we have our stem thickness is going to be 0.1 times h, which is 0.1 times 7 equals 0.7 meters. So if I have a restrained, or if I have a wall with a 0.7 meter thickness, what this means, along a large length, this wall is going to require a huge amount of concrete, which is not really an optimal design. It's not feasible for us. So this is why we usually try to opt for an alternative, which is my restrained retaining wall system. Why? Because when I go for a restrained retaining wall system, I'm providing my retaining wall with a lateral support. And this lateral support is like a steel anchor with a concrete block at the end here. This is a concrete block. And what this happens, or what this does, is that it changes the behavior of my wall. So to better understand the change in behavior, let's draw our analytical model. So here, if we have a fixed end here, or we can take an example of a pin. Now we are going to have a roller on top, so the bending moment diagram of a fixed end here from a restrained wall system is going to look like this, whereas this here is going to look kind of like this. Now we can see here what we did was that we were able to reduce the negative moment that we have here. So this way, when we reduce my negative moment, what I'm doing is that I'm reducing the amount of reinforcement that is required, and moreover we are reducing the thickness, the stem thickness that we need. So we don't have to go for a 0.7 meter thickness if we are working with a 7-meter wall. So this is why we usually go for a restrained wall system, to try to reduce the moment that we have and reduce the thickness of my wall and reduce the amount of reinforcement that we want to use. Now, another thing we notice here, a main difference that we notice between my restrained retaining wall and my cantilever retaining wall, in my cantilever retaining wall, our bending moment diagram was along this direction here. It was all on one side, so we required reinforcement from this side only. However, here we can see that we require reinforcement from both sides. Now, if we have a pin, what we are going to do is that we are going to add a reinforcement here from one side, but we are also going to add a reinforcement from the other side as a temperature and shrinkage reinforcement. So this is why it's very important to draw our analytical model for our retaining wall system, or any structural system, to understand the behavior of our wall and to try to differentiate between the behavior of the different retaining wall systems. Now, let's say we want to work with this model or this retaining wall using software such as SAP or such as Robot. So what we do is we draw a beam element which is fixed from this side here, and has a roller from this side, and we are going to draw a uniformly distributed load that has a magnitude that is equivalent to K A gamma S H. Now what we are going to do is we find the bending moment of this model here. Then we apply the Feynman equation, which is basically the capacity rule that we have, and we find the area steel. Now the reason we don't tend to go for these software SAP and robot is because they don't go through stability checks. They don't check for stability conditions. So this is a very important point that or a very important feature that ASDIP has in order to increase the accuracy of my analysis. So this is why we are not using SAP or robot to model or to analyze my retaining wall system. This is why I refer to ASDIP. So this is going to be it for the quick overview behind my restrained retaining wall system. In my next lecture, we are going to design for a 6-meter wall, and we are going to see how we are not going to require a 0.meter thick stem or stem thickness of 0.6 meters. We are actually going to use a thickness that is lower than that, and we are going to satisfy all of our criteria, and we are going to have an optimal design. So this way we will see the functionality of my restrained retaining wall system in action in our next video. So I'll see you then.